I have different types of these devices here. This is a 24 volt model, and as you can see it from a closer perspective, 24 volt DC is quite obvious here. Thank you. The other model is 101 110 volt, which is here, and because the phase 110 volt is a little faint and light in color, it might be a little bit difficult to be read. I'm not sure if it's visible, but I think the phrase 115 volt is clear. Okay, that's great. The mechanism of action is the same and there's no difference, just items varying amount of voltage, their core requires, and supplies. As you can see, these are 3 holes here, 2 in the back and 1 in this part, which is obvious as well. The connections are 1/4 inches and the air tube will be connected to them. Connection 2, as I point with my hand, and you can see that number 2 is written next to it, and also connection 3 are commonly used in connections. I mean, for example, the air tube is connected to connection 3 and exits from connection number 2. When you put the voltage on it, connections 2 and 3 are connected to each other, and when you remove the voltage, exhaust will be done from point 1. I've already opened the screws of this device. As you can see, this equipment is a little bit difficult to be opened because it is a explosion type standard coating, or in fact it's the EX1. By looking at the cap of this equipment, you will realize how strong it is, and it's fully attached to the body. It has an appendage that is attached to this part of the body in this way. As I mentioned before, this equipment is a DX model, and that's why it's very heavy. This equipment is made so that if a spark occurs while connecting voltage, the spark damps inside. This is the EX standard requirement of a flammable proof. Let's see the connection inside. I want to show you some other things in detail. Positive and negative items are clear here. It only needs to be connected to a 24 voltage DC to energize the coil, and which in turn leads to be connected. And 2 and 3 connections are going to be connected. Okay, guys. At this episode, I want to test the solenoid valve. As I said before, and you remember in previous episode, I showed you the solenoid valve equipment, and also you saw the inner part of them. Now I want to test it. As I mentioned before, you can easily find the input and output loop by reading its catalog. As I saw in the catalog, number 1 is the air inlet. Number 2 is the air outlet. Number 3 is the exhaust. In other words, if I do not give 24 volt DC to this device, it means that it is not energized, and I give input from 1, it will exit from number 2, and vice versa. 2 and 3 are no longer connected. Let's do this test right now. To do the test, I use a pressure gauge and install it at the outlet to have the pressure changes. Let me install the pressure gauge on outlet number 2. It is being installed now. Okay, it's finished. And I want to use a hose converter to fasten it to part 1. I mean entry number 1. So let me bring the air hose. Wait, please. This is the air compressor, and I insert it in this way. I open the compressor valve slowly to see the change on the pressure gauge. As you can see, the pressure gauge shows a 3-bar change, which is quite clear and obvious from this perspective. Yes, you can see exactly 3-bar change on the pressure gauge. I mean the black item marked with a bar. 3-bar change is quite clear here. Now, I want to use a power supply. I've just set it on 24 volt DC. The red color is positive and the white one is negative. Let me just rotate it a bit. I want to make the connection on positive and negative terminals that I want to show you. When you hear the sound, please do not be afraid because it sounds just like an exhaust. As you observe, the pressure gauge becomes 0 and I take it out of the connection and it is actually airing again. And as you can see, it's 3-bar again. I mean, exhaust is done and it's 3-bar, then it's going to be 0 right now. That's great. As you observed, you could easily put this solenoid valve into the service.